This is our third screencast on pointers, and I want to talk this time about passing pointers to functions. So let's first just create a function. It's not going to return anything. Let's call it change my parameter, change the parameter here. And what I want to pass in is a pointer to some, let's just call it mutable value. Any name works, and what I'm going to do is I'm going to take what gets passed in, and I'm going to dereference it, and I'm going to assign it the value 100. Okay, because normally when we pass in a value without pointer syntax, we can change things in here and it doesn't affect the calling program. But this works a little differently because we're pointing to a specific memory location. So let's just say int my value equals 100. No, sorry, we want something different, 123. And then we're going to call this function change parameter, and we're going to pass in, remember it wants a pointer, so we can't pass in my value. If we try to do that, we'll just get a warning, and if we let's try and compile this, this should give us an error. Okay, so there's our error. It's going to tell us invalid conversion from int to pointer to int. So what we have to tell it is I want to pass the address of my value in, and now this will compile. Okay, and then let's see out this. Now this generally isn't a great thing to be doing, to be passing in parameters and changing them, because a lot of people don't expect it. Now somebody reading the code gets a hint because you're passing in the address here. But especially in this case, if you were just changing one value, you would want to return an int and do your change that way, not change the value that's passed in. But this is for just showing how pointers work again. So let's go ahead and run that. Okay, so you can see I signed it 123, but what prints out is 100 because it passed in the pointer and it changed its value to 100 up here. Okay, which kind of leads us nicely into this other syntax that C++ has. Most of what we've talked about has been true for C and C++. But C++ added a new syntax, and it's called reference syntax. So it's, again, they reuse the symbols. So now instead of creating a pointer you create with that, you use the ampersand again, but this doesn't mean address of anymore. This means a reference. So now I'm going to pass in a reference to an int. And what this does is it really gives you a pointer, okay? But the syntax, it cleaned up the syntax you used to treat a pointer. It says, okay, I'm going to take a pointer, but you don't have to use this syntax to dereference the pointer. And when you pass it to me, you don't have to use the address of. I know you want to pass this by reference, so you want to pass the address. So you don't need to use the ampersand address of operator. That's all. It's just a pointer with a cleaner syntax is in effect what happens. So now we've taken out the dereference, we've taken out the address of operator. This should work the same and should give us the same value. Okay, so 100. So you'll see references used a lot, and sometimes passing things by reference, passing a pointer which is 4 bytes long can be a lot shorter than, say, passing a big long string. So a lot of times what you'll see is something like this. So this is I'm going to use the built-in class for string. Okay. So, those 8 or 9 characters would all get copied into a function, but if we pass it by reference, that won't happen. So, let's just call this print parameter. So I'm not going to change it. So I'm going to say, hey, treat this as a constant. It's a constant string, and it's passed by reference. Okay, and so now I can't change the value of what's in string, but I can still do something like this. I can still print it out, and now it only passed in a pointer. It didn't have to pass in the entire string here. Okay, so down here we then want to say print parameter, and we want to, now remember it's a reference, so we don't need to use the address of, we just get to say that, and then we can run that code. There you go. Now I don't have a new line, but you get the idea. So if I did want to change it, I could get rid of the constant. I can change it. But one of the things you see a lot in C++ code is you see a lot of things being passed as references to consts. especially when we get into classes and things that take up, big structs that take up memory and whatever. Just passing a pointer to them can be much more efficient than passing in the whole thing. And when we just want to read the values, then it makes sense to use this const keyword to make the promise that we're not going to change anything there. Okay, so that's a brief introduction to the references as they relate to pointers. I should say one more thing about references. References have to be assigned when they're created. You cannot do this, my reference, and not give it a value. We'll get an error here, and it'll say my reference declared as reference but not initialized. So this is a reference to an int, so it wants something here. So it wants to know what is it referencing, and here you can say, okay, I'm referencing my value. Okay, it's just saying it's unused. So and you can see I don't have to use the I don't have to take the address of my value. I can just give it my value, and then if I want here, I can just come here and say cout my reference. And I think we had some stuff here already without new lines, so let's put that in there as well. Okay, so then I printed out 100 again because we still had the code in here that was changing my value right here. So if we take that out, and now we should get our 123. Okay, just like that. So the point of that was just that you can't have a reference that's not initialized. A reference does have to be initialized when it's created.